Okay, so here we have an RC response circuit, and we are trying to find the voltage between here and here at 0, or the initial voltage at 0. And you'll see here right at the circuit, this is pretty much what we're trying to find. So first, what we're going to want to do is we are going to want to find the voltage that this capacitor is going to hold, or the initial voltage that it holds. So what we can do is we'll just start by redrawing the circuit with the switch closed and calculating the charge, the voltage charge that that capacitor is going to hold. Oops. So we'll first just close that switch. And then since this is a capacitor, one thing we want to remember is that we want to try and get this source to become a voltage source. So what we can do is we can do a Thevenin source transformation. And to do that, we can just do 7.5 milliamps times 80K, and that will give us voltage. And just doing that in the calculator, we get 600 volts. So we can just erase this, move the resistor up here in series with the voltage source, and get 600 volts. And then we can also combine these resistors because they're in series. So we can do 80 plus 20 to get 100K. Okay, and now we can just do super simple node analysis to get the voltage at this node A right here. This node will be 600 volts. And if you remember node analysis, it's going to be the node A minus 600 over the resistor that's in between plus A, and then we'll do that, so plus A over 50K equal to 0. And then to make these denominators the same, we'll multiply this one by 2. So we'll get A minus 600 plus 2A equals 0. And then just combine like terms, we'll get 3A, move the 600 over to the other side of the equal sign, getting 600, and then A will equal 200 volts. So the answer to our first question right here, where the initial V at t equals 0 is going to be 200 volts. There we go. And now we want to find tau when t is greater than 0. So to find tau, is, here we can change colors, tau is this symbol right here. And for a capacitor, find tau, we do R times C when the switch is open. And the R that we're looking for is the equivalent resistance that the capacitor sees when the switch is open. So we can paste the circuit again right here, and then now we want the switch open. So when the switch is open, we see that basically all of this gets cut out because we only are focusing on this part of the circuit when finding tau. So when looking at that, we see that the only resistance that the capacitor sees is going to be the 50K. 50K. Actually, let's change that. 50K. And then we need the value of the capacitor, which is 0.4 microfarads. Let's make this smaller. And move it down here. Okay. If you didn't see that, so there's that. And then, yep, we multiply those two together. Let's rewrite that. 0.4 microfarads, and that's going to equal, using the calculator, 1, 2, 3. We get 0.02 seconds, because tau is in seconds. Okay, so we have that, that's the same thing as 20 microseconds. So now that we have tau, now that we know that tau is equal to 0.02 seconds, we need to find v of t after the switch is open, so greater than 0 is equal to, that's what we're going to be trying to find now. So what we can do is rewrite the circuit again, because it's always good to rewrite the circuit just to make things more simpler on your eyes. So we want it when t is greater than 0, and we see that the circuit opens at 0. So we'll be looking for when the circuit, or when the switch is open. So we can pretty much just ignore all of this other stuff on the left side here, and focus on this right side of the circuit. So we know that this capacitor is going to have a voltage of 200 volts. So what we can do is just replace this with a voltage source of 200. Okay, and then we can just actually, no, we don't even need to do that, because the circuit is quite simple. We can just go straight to writing v of t. So the form of the equation that we're going to be writing is going to be x of t e t negative t over tau. So that's the form that we want. Okay, so this x of t is going to represent the initial voltage or current of whatever kind of circuit you are trying to solve. So we're trying to solve voltage. So what we're going to do is just the initial of this current, or of this voltage that the capacitor is going to output, which is going to be 200 e negative t over, and then our tau, which is 0.02. And that is our voltage across this, or the discharge across this capacitor of voltage. But you'll also sometimes see the equation written like this. So I'll move down here just really quick. You also see it sometimes written like this, 200 e negative, and then we get the inverse of tau, which is 50 t. You'll also see it sometimes written like that. Okay, one more thing we're going to find, or we need to find, is the initial energy stored in the capacitor. So we want to find the initial energy stored in the capacitor. And if you remember, the equation for the energy in a capacitor is 1/2 V or 1/2 CV squared. So this is quite simple. All we do is just plug and chug, and we'll do 1/2 and times 0.4 times 10 to the negative 6 times 200 squared. And then if we do that in our calculator, we get 0.008 joules or 8 millijoules. Okay, so now we want to find the length of time required to dissipate 84% of the initially stored energy. So in order to do this, we're going to take our energy equation from up above and rewrite it with this as our voltage. So we'll just rewrite 1/2 C, and instead of V, we want V of T, because we're trying to find T. So plugging in our variables, we'll get 1/2 times 0.4 times 10 to the power of 6 times 200 e to the power of negative 50 t squared. This needs to be squared. Now, in order to find 84%, we need to find, we need to take 84, or 100 minus 84 to get 16%. And then using 16%, so 0.16 is the same thing. Multiply that by what we found, which is 8 millijoules, 0.008, and that will equal 1.28 millijoules. So that is what we're going to make this equal to. We'll just write out the whole thing. 0.128 joules. And now we're just going to solve for t. So we'll change this. We'll just change this to 0.5 to make things easier. 0.4 times 10 to the power of negative 6. And then, so we need to distribute this to the 200 and then to the e. So 200 squared is going to be 40,000. 40,000 times e, and then when we do an exponent of an exponent, we just multiply them. So we'll get negative 100 t, again, equal to 1.28 millijoules. Okay, and then we will just multiply all this together in our calculator. Negative 6 times 40,000, and we get 0.008 e times 100t equals 1.28 millijoules. Okay, then we just divide our 0.008 on both sides. And we get 0.16. So 100t is equal to 0.16 joules. And then to get rid of this e, we're going to take the the ln of both sides, so we'll get ln of e 100t e equals ln of 0.16. And doing this right here, we'll cancel out the e and we'll just be left with 100. Negative 100t is equal to the ln of 0.16 negative 0.1883, and then we will just divide the 100 or the negative 100, and we will be left with t is equal to 0.018 seconds, or 18 milliseconds. And that is our answer for that question.